Hello everyone, welcome back for those who have watched before, and welcome to those who haven't. It's time to do some more programming. It's time to do some more work on a processing library for Kafka streams with Node.js. And for those who are unfamiliar with what that is exactly, I have my old Twitch videos, which are about to expire. So let me actually really quickly post the link to the public videos about this in the chat. It's the best thing to do is to say during a live stream, go look at this stuff elsewhere. Anyway, that's the link. And that's where you can go if you want to know more about what this is exactly and what this does. So I've done a little bit of work since the last time that I've live streamed about this, because I've been busy. My little sister got married, which is really cute, which was really nice, and so I've been able to fit in bits and pieces of work. Let me actually adjust this for a bit. I've been able to fit in bits and pieces of work, but I've had a hard time actually sitting down for an hour and a half, clearing my mind, preparing everything in order to do a live stream. But I really want to keep doing them. So what has changed since last time? I know a lot more about TypeScript, which is good. I can't say that I'm quite the expert yet. It's just that I've gone from seeing syntax twice to actually have written some of it a little bit, and know vaguely what I'm doing-ish. So we can test this thing, and all the TypeScript should compile without any issue, and all the tests should pass. And for those who are really have been really paying attention, how big does this have to be in order to make this fit? We've got these. Oh, sorry, I should actually switch to this view. There we go. Now you can see what I'm doing. Is this all readable? Is this all big enough? I hope that it's all big enough. I think so. Let me know if it's not, and then I can adjust the size a bit more. So basically all the tests run. And for those that have really been paying attention, actually been paying attention, there is this new test suite. And basically, let me grab the example. I've been working on the inject interface. So this here is an example of a processor as I have it in mind, where you define the source of the topic you want to consume. Then you say, okay, I want to define a processor over that. You do any setup work for the processor here, and then you return the actual processing function, which is an asynchronous function. But at the same time, instead of directly connecting to a Kafka cluster, what we really want to do, and what I've found extremely useful in other libraries that I've used that deal with method external dependencies like this, but in a very defined way, it's really nice if you can actually just inject messages. So rather than having to connect to a cluster, write stuff to a cluster and write tests that way in order to test your processing logic, you can actually just insert allow with an async function. Oh yeah, okay, this isn't wrapped. Anyway, this is not an actual example that runs, so that's fine. So you can actually inject messages. You can say, okay, this is the interface that we're working with, and this is the assignment that I want to process. So this is an incoming assignment, and then for this assignment, these are the incoming messages that we're consuming. In the projects that we've been using that, ever since we added that, we have a lot more confidence in our processing logic. It's so much easier to test. It's so much easier to see like what are bugs in the like in the processing framework, and what are the bugs in the actual processing itself. But as you imagine, because we're not actually connecting to a Kafka cluster, that means that we have to build an interface, basically a mock Kafka cluster. Now that's very complicated, and we don't actually want to build a whole cluster. But what we do want to do is implement sort of one topic partition of that, if that makes any sense. So the unit of concurrency in Kafka is a topic partition. So it's basically partition, but a partition is always viewed in the context of a topic, because it is the topic that a partition partitions. It's where it's that concurrency where the implementation of Kafka gets really complicated. Doing stuff like consumer groups and joining and leaving and syncing, all of those, that's the really complicated stuff. But when you actually look at the topic partition itself, there aren't that many things you can do. It's basically a log of events that goes, that has a start and an end, that's only immutable, so you can only add messages to it, you can't remove them. Kafka can, under some circumstances, clean some of them up, but at the same time, the offset number, which is the position in the log for each message, only increases monotonically. There are some really good guarantees around that sort of stuff. And so that's actually what makes programming against Kafka relatively possible, is that as long as you're thinking in the mindset of a single partition, stuff isn't too complicated. So we actually have a pretty good chance of implementing that. So I've been doing a bit of that. I think this example was here last time in the last live stream that I've done, but some of the implementation hasn't, and it isn't much yet, because again, a lot of that was me figuring out how TypeScript works, fixing some problems that I had introduced before because I didn't know how TypeScript worked. Let me get the actual task in place. Now I actually want to look at this test. There's a little bit more that I've done, but I just don't want to get into every single nitty-gritty detail. So the thing that we're testing is the assignment context. Now this assignment context is the thing that comes back. Is basically the context of our particular processor processing a particular assignment. And what I call an assignment is basically, well, you actually see it here, it's a topic, a partition, and a group. A group is the thing that makes it particular to our processor. But as far as I am concerned, that's what the most basic thing of an assignment is. There's a little bit more to it, but that's basically what it is. And so I've been working on the most important bit of that is the ability to inject messages. So there's this test interface, test.inject, and you can see actually a little bit of that code from the example. So over here, actually, so we create this test interface. In a way, we pass this test processor to it. It doesn't really do anything. It just like with process message is like a spy, it's like a function that records how many times we call it and what we call it with, so that we can test against that. And the test processor itself actually doesn't do anything. It just says, okay, well, return the processor, because the thing that we want to know is that if we inject a message to this test interface, and that's actually the thing you get back when you call task.inject, which is tested somewhere else, but you get this test interface back, and that gives you the tools in order to simulate the states in your Kafka cluster. So we take a message here, we inject it into the interface, and then we just want to make sure that that we actually get that back, because we get the injected message so that we can work with it. That has a couple of reasons why you get that back. One of them you can see right here is that messages coming through the assignment context are always encoded as a buffer, and well, the key and the values are encoded as a buffer, and over here we passed in a number and a string. So we want to make sure, okay, we've actually implemented that is coming in the way we want it. And then there's let me see what we're doing here. Message to string, JSON parse. Oh yeah, we're actually making sure that this is what that is, that by default we're just encoding things as JSON, basically. That's just the encoding we're using for this for these test purposes. We can inject a message without a key or a value, so that we actually don't have to give a key or a value, because you can inject messages that way. They can just be null. But we also want to know that we can actually that if we do actually provide a buffer, that we don't then do any coding on top of that. So if part of the processing logic, which is the parsing of the messages that comes in, which is pretty likely, we want to be able to inject messages with the right encoded message, so that your parsing works. And then it increments the assigned offsets for each subsequently injected message. So that's basically the thing. Every single time in Kafka, when you write a message to a log, that message gets an offset, and that is always increasing. And so we want to make sure that we don't have to manually say, okay, this is the offset of this message, this is the offset of this message. Now we just want to tag each message with a monotonically increasing number, right? And so that's tester interface inject, and then over here we start testing the assignment.send. So the assignment.send is actually a function you would have in a processor. So you can actually see that inside, this is our test processor that we're defining here, and in this test processor, we're actually in the setup stage, we are sending a message. We're sending all these test messages, and we just want to make sure that one, we can then read them as produced messages, because if this is the thing we're testing, and we want to make sure that we can assert whether those messages have been done. This is actually probably where we'll pick up the work, is that I've already tested it. Not extremely rigorously, but basically we want to know that if we inject a message back into ourselves, so if we're writing to our own assignment with an assignment, which is totally possible and totally a legit thing to do. There are definitely use cases where, especially in certain, when you're trying to replicate from a remote data source or from a third-party data source, like we've written events to Postgres before, and we wanted to make sure that we write them all to Kafka in a way. Then that was a technique we ended up using. So now let's see where we're gonna take this off. So actually, when we look into the implementation, we'll see where we can take this. These are the types that I've been defining, which still has an any here, but as before, as I said in a previous stream, I don't want this to become a let's all learn TypeScript together stream. So whenever I'm not sure, I'm just going to continue on with something. So this is the implementation. This is a function that accepts the assignment as it is received, accepts the processors that need to be the processing functions that we've used earlier, and then actually applies them to a stream of messages. And over here, you can see that we've implemented the send, and that we've implemented this inject message function. And but then there's a whole bunch of stuff that is still empty, and that's what I want to go do. That was a very long 10 minutes or 15 minutes way of saying I'm going to continue where I left off last time. Stuff gets a little bit more complicated here. A complicated one is seek. It might be an interesting one to do. Pause and resume. I'm still not sure that's something that we want to support, because we also have heartbeat. If you don't know exactly what those things are, maybe one of my previous videos. Otherwise, otherwise Google is your best friend, I guess. It's a little bit too much to go into right now. Watermarks is relatively simple, but I think seeking is where stuff is going to get quite complicated. So maybe we should do seeking first, because then we can, because we have to put a lot of stuff in for seek, and for seek to work correctly, we'll need to implement that, and then we can do the watermarks after that. Yeah, because basically seeking an assignment, maybe we should just start with test, really. Inject. Is this okay? First, I'm gonna start this thing. npm test watch. So for those who've joined us today for the first time, I'm going for 100% test coverage. So I'm gonna keep the tests running, and if we don't get the coverage we want, then there might be a bug in our code. And test coverage is this really useful tool to detect that. So let's get that one over there, and let's see what we do with the offset. Now, so this is the, we'll take an offset as the input. Now, so what is seeking? What does that do? I think the best way is to write a test, and then that's the best way to explain it. T.test assignment. It's maybe not the best way to explain it, but it is a way to explain it. Seek. Yeah, let's just keep it up there. No, because my OCD is saying if we're gonna do this by alphabet, then this fits over there, and then we can remove that. That's how that works, right? Assignment seek double E for, yeah, makes sense. Okay, cool. So we're gonna process the message. Oh. We'll make that a spy for now. Let's just say, let's define the test processor. Wait, what did I do here? Oh, wait, did I create some? Oh, I created a little bit of a helper here in order to set this up a lot easier. Okay, so we'll just look that up there. Test interface is a way to test processor. Return process message. That's fine, because we don't want to actually do anything during the processing of a message in this case. For now, just to keep stuff simple, I just want to do it during the assignment setup phase. We'll definitely want to at some point add coverage for the fact that you could do those things during the processing of a message, but then there's probably a different context that I want to use for that, which I haven't even explained yet. So we're just going to keep it like this for sure, so we can verify that the implementation of the test interface works, of the test of the assignment context works, and then we can deal with all the minutia after that. So, well, then I guess we're going to have to call that seek function, shouldn't we? Assignment send, and then we need an offset. Now this is where we're going to run into a little bit of a thing that we probably have to do first. So, oh, not send, seek. So I want to say, let's seek to offset 2. But that 2 doesn't really mean anything at the moment, does it? Because there aren't any messages in the in the processor at the moment. So this actually doesn't make a whole lot of sense. So we could use this assignment send function first and send a whole button, like, just say, okay, well, we'll take some test messages that we've defined here. Probably should create a little bit of a helper to create those as well, but it's fine. Test messages, we can where and how we inject those. So we just use send. Yeah, because we don't have that. See, this is where the problem begins. But let's just send, like for test messages, for each of the test messages, test message. How about for each of these test messages for each, how about for each of those ones we see this is already going to fall apart. This is not going to be what we're doing, but let's just say, assignment, send that test message kind of thing. But it's really nasty, and we're running into the fact that for each doesn't take asynchronous functions, and then we need to do stuff differently. No, don't want to do this. The thing that I want to do is that at the moment that we create a test interface, I basically want to be able to say, this is the state of the topic partition. These are like, there are already messages in there. There already is there are already watermarks there. It's really important, because obviously right now we can do this whole thing where in the test processor we're gonna inject a whole bunch of fake messages. But what if we're testing an actual production processor here? Then obviously we don't want to add all this test specific code in our actual code that will run in production. It's really weird. So there needs to be a way where we can tell this interface, okay, this is how the world starts. This is the initial state of our partition that we're processing. So given that, it might actually be easier to do watermarks first, because watermarks, so let's get this back to where it was. Watermarks is a function that returns the high and the low offsets. So the highest existing offset and the lowest existing offset within the of the topic, which is so basically we want to say this should return a high offset of, I don't know, 2 and a low offset of 0, and then we know that there are messages in there. We don't necessarily know that it's 3 of them, but we know that there are messages in there, and the message with the lowest offset is 0, the message with the highest offset is 2. And so that if we seek beyond the highest offset of 2, we're not going to find any messages, because that doesn't exist in that log yet, because these things will always increment, right? So let's do watermarks first, because it's really easy, and we can test. So let's get rid of this Istanbul ignore, which is the coverage. That's the little thing that makes the coverage ignore that line, and that cool. And then line 105 isn't covered, and that's right, because that's over here. All right. So I think if we just call this with assignment watermarks, how do we test this now? I guess we could just write a source in here, can't we? Probably. So it's an asynchronous function, because it might have to retrieve it from the broker. There are points, especially I think Kafka.js, that tries to keep track of that and tries to keep this sort of metadata in place. But I found that in a lot of cases where we've used this is we actually need a fresh number. We need to make sure that the number we're getting for the watermarks is up to date. And wasn't some stale value that was up in a cache somewhere. So even if we end up deciding using a cache, we should be able to fetch it from the broker, and therefore it needs to be asynchronous. Let's say I want watermarks to be deep equal to high offset of 2 and low offset. Now this is a really easy way to make your test pass. Just, hard code the whole thing. And it should work. Yeah, see, test passed, code coverage 100%. Sweet, next. Not quite, obviously, because this doesn't do anything yet. But the thing we want to do, so here, instead of obviously setting this manually and hard coding this manually, we need to figure this out somehow. So we are keeping track of a list of messages, injected messages, which is an array of internal messages, and that's basically our log. So maybe we should rename it a log. Maybe we should. Nomenclature log isn't, I really like the idea of an event log and a change log, but it is a partition. So I'm just going to keep, anyway, see, this is what developers do. Well, what's this supposed to be called? Let's debate that for 3 hours. It's exactly the kind of developer I don't want to be, so I'm just going to keep going. Injected messages is basically our log of messages. And so actually looking at this array of messages, we should be able to figure out which is which. So I'm just going to inline it, because just inline stuff until you have a reason not to. Is injected messages. They'll be injected in order. So can we just look at the last one of that? I think so. Injected messages length -1. Let's actually just last message. This is the way to do that, right? Yeah, I think so. And first message. See, this is where I normally use Lodash, and that's why I'm thinking that's not right, is it? Because that's going to be 0. To Google. Because as one of the goals we've set is that we want a minimal amount of dependencies, and I use Lodash for these kind of things, and a lot of people say you don't need Lodash, and I agree with them, but it's something that I've used for years and years and years on end, and therefore in Lodash I would just use last, and it picks up the last thing because it's a useful thing. But because we don't want to introduce that as a thing, I'm just going to say, okay, what is the way to get the last version of that? So I'm going to let GitHub churn through a couple thousand lines of code while it highlights the length is array is null, length array. Yeah, okay. You need to bound check the array, obviously. Makes sense. 2. Let's see how our friends of Kafka.js have. Are they just including a thing? Let's look at the source of some other people. Utils. Array diff, concurrency, lock, flatten. Yeah, concat apply, that's the way to do that. Okay. Just gonna follow their lead. But then I don't know how to TypeScripty thing. No, not gonna let this slow me down. Long Island. Oh, Lodash. Because we've got one of the later goals is to have very, very few dependencies. And I'm actually going to, because you can, I'm going to only use this function, which is hopefully still a thing you can do. I mean, of course it is still a thing you can do. Right? Lodash lost. Yeah, sweet. I don't know if this is still the recommended way of doing this. When has this been last updated? No, not Lodash documentation. Per method packages. But we are using SES modules. Because tree shaking is a thing, is it? No, because I don't want to use any Lodash stuff if I don't have to, because it's only going to make it harder in order to like move away from it again. So we're going to do the whole per method package thing. Lodash modularize. Yep. Okay. Lodash lost. We're just going to use that because it's not something I want to lose too much time on. Save. Lodash lost. Sweet. Have to install. I wonder if that works with. Does that work with? Does this thing have a? Whatchamacallit, a TypeScript thing? Does it have a TypeScript thing? A lot of people are like, you can just write those couple of lines of code yourself. And exactly, yeah, but so many of these things have like little annoyances to it and stuff like that. And especially something like Lodash is one of those things where like it is just an extremely useful utility belt, of which I almost never end up using one function. I always end up using quite a bit of it. Let's just see how this goes, and we'll see how that. Let's just see how we go with this. Because then we can just say lost of that injected messages. I'm not being super stupid and an array just has this, right? Yeah, see? So even they're saying, just do that. But what if your thing is empty? Yep. Okay, there doesn't lost index of, yeah, okay, so there is no actually, see, there is no lost. I'm all like, why would you use that if it's, I don't want to use Lodash for stuff that is supported. And then we need first as well, don't we? Let's just go with that first, whatever. It's another good example of me trying to set myself a clear goal. I was like, no dependencies. And then like, I kind of like these dependencies. One or two of them, not very small ones. Like well tested, well respected. Can I get away with it? Maybe. I mean, I should just do whatever the hell I want to do, really. But there are really good reasons for not having a lot of dependencies. Oh. Wait, this does actually return undefined. See, we're getting here now. All right. I should have checked before I tried. And I could probably just say, can I just say 0 here? Because obviously injected messages is empty at this moment, so. First message. Yeah, it actually just returns undefined. People, let's delete the last 5 minutes. But you know, that's just what this stuff is like. Low dash. This did work, by the way. But anyway. It's just the way this stuff works. So you try something new, you learn, you have to falter a bit. Okay, now, obviously there isn't always going to be a last message, and there is always going to be a first message. If there is a last message, then take the last message and take the offset of that plus 1 is I think what we need. Because the high offset is always what is the next offset going to be, basically. Otherwise, we'll return 0. Or do we return -1? I'm going to go with 0 and until we find a reason that that's not the right thing to do. Low offset. Is there a first message? If so, first message offset, please. And otherwise, 0. Makes sense? I think it makes sense. What are we complaining about? Can I be applied to types of long? No, that's a long, so we need to do add 1. Because in the internal message, it's a bit of a thing. That's actually basically the main difference between an internal message and between a external message. So actually a message as the framework would see it, or the consumer of the framework would see it, is that offset is a string. And that offset is a string because an offset can be up to 64 bits. And the JavaScript numbers are only 50... to the 53rd -1 instead of 2 to the 64th -1. So it needs to be a string for the consumer. We don't want to push long onto people, but at the same time we need to be able to do arithmetic with this offset. So but at the same time, wait, did we kept the produced offset as an integer? Yeah, okay, because we know we shouldn't definitely not produce anything ourselves much higher than that. But maybe that's a mistake. Anyway. Bugs that aren't interesting yet. So this needs to go to string. And this needs to be a string as well. This needs to be a string. Returns a string. Oh, no, it returns a promise of a string. See, I'm learning. Returns a promise of a string. Sure, string will happen. Trust me. ToString. What is the complaint about? Oh, of course it doesn't return a string. It returns an object with a high offset. It returns a promise of an object with a high offset as a string and a low offset as a string. Yeah, that's more like it. Exactly, and now it's just complaining that it's not getting the right thing back. And that's right, because we've still hard-coded these numbers over here. So, I mean, we can probably leave this as a test. Yeah, we probably could. It's just basically saying, you know, if there's no messages, then this is what it's going to return. That's fine. But obviously that's not the only thing we want to test. We also want to test what happens when we do inject messages. And you can tell from the code coverage here, the branches, is that 109 and 110 aren't covered. And you're like, okay, what's 109, 110 about? And it's like, oh, actually, you know, coverage of the branches does not meet the global threshold of 100. And then you can see, okay, yeah, obviously this is, you know, tertiary operator. So we're only hitting that branch at the moment. So again, very useful in that way. Watermarks is await assignments, watermarks. Why does watermarks take a 2? It doesn't. That is with seek. Now comes for the interface where we inject some messages here. So this is the way I want to do this. The test processor here. As part of the assignment that we get here, I want to start accepting more values, not just the topic and the topic, the partition, and the group. I want to start adding extra stuff like that. So I want to start adding messages to that. Have we typed this anywhere? No, we haven't. Let me see. Let me actually write here what the thing is. So I actually want to sort of just be able to pass this option, and in the same way that we've been sending and injecting messages, this is basically where I want to say test messages, which you define over there. This is how I want to be able to insert these things, so that before we do anything, before we start consuming this stuff, we can have the mock cluster primed and set in a certain state. Let me check the time. I still have some time to do this. Good. All right. So this doesn't compile. Not assignable. So where have we said that that's the thing we will accept? Is it just here? Wait, this needs to be, actually need to be entire an assignment. I'm passing in, by default, we're passing in a test assignment here, so we need to go do this. What is this? Argument of type messages. Yeah. Does not exist in type. Okay, so where's that type defined? Can we know about that? I said this wasn't going to be a thing about TypeScript, but here we are. I guess it can't be defined in that many. What are we calling here? Create local assignment context. Aren't we just calling create context, right? Yeah, that's what we're calling. I'm happy for that assignment. I'm just doing type inference somewhere. Right? That's what it must be doing, but from where? Test assignment, okay. Gets passed in there. What do we do? Is assignment anywhere else? Nothing in particular. Is it? Ah, wait, it's probably getting it from here. That is probably what it would be getting it from. Can I just ignore this and see what else? May only specify non-property message does not exist in type. Yeah, but where does the type come from, mate? Where does it come from? I'm gonna see if the type inferences changes. If we could just say, if I say no, this is actually a thing we can do. Let's just, okay, produced messages, assignments. I'm just gonna start using it and see what happens. So we can't just put it into injected messages. That's not going to work. Initial messages, because that's basically what we're doing, saying the initial value. Now, does this change the type reference here? Does it say, okay, should be fine now? Huh, I think it might have. I mean, it's also blown up a whole bunch of other things, but. $107. Have to stop looking at that so much and just deal with it as it becomes an issue. Injected messages is internal message. Okay, now, as we inject a message, we assign an offset, and we make sure that all the conversion of the value and key has done. And basically, because we want to make these messages work it's the same way, we're going to have to basically do that as well. But obviously we don't want to actually inject the message at that point. Or is that not that big of a deal, actually? Maybe that's exactly what we want to do. Let's try it. Because it injects it in the messages, so it gets into the right array. And it adds it to the stream. Ready for consumption. Which is probably not the worst thing in the world. No, okay. That's the context, sure. Processed stream. That's where we set up the whole. So this is where we start setting this stuff up. This is where we start running the processor setup functions. So we want to do it before then. We want to say initial messages for each inject message. Let's do that. And then we want to say, here we want to say t deep equal. Wait, first we want to return process messages here. Marks. Zero, 1, 2. So we would expect low offset would be still 0. Messages not available. And that's what we saw earlier. Sweet, and that's actually still an issue here. Let's just take this step by step. Yeah. Why is C duplicate? Oh, yep. No, of course that's not right. Initial state is, and we want to merge some defaults in with that initial state. Which could be empty, so let's just deal with that. And then, so we set messages, right? That's what we want. That's what we want the thing to be. Yeah, okay. Let's forget about the types for a second. That's empty by default, and then over here we can just say initial state. Messages. Probably don't even need to do that anymore then. Initial state, where do we do that? Initial state, dot messages for each inject a message. Okay. Now we haven't actually injected that anywhere yet, so what are you crying about now? It's missing. Can I? I'm gonna have to type this, aren't we? I think that's just where a lot of this pain is coming from. Simon, any, whatever. Processors, any, whatever. Initial state, any, whatever. But I think this is what we need to do in order to make sure that it's not necessarily required. Yes, okay. Now it's not actually required. Now we still need to just insert it in this though. Test assignment, and I guess we can just keep that separate now, like initial state, messages, test messages. That's probably actually the cleaner way to do it anyway. As test assignment, initial state is empty by default. I know what we can do here. Just keep this and default value. I reckon that should work. And then okay, revert on that. Revert on that. I shouldn't be trying to be clever here. Okay, and now it says the high offset is 3 instead of low, instead of 2. Which is right, of course, because the high offset isn't the actual highest offset, it's the highest offset plus 1. So maybe we can formalize. No, let's just keep that hard-coded like that, because you can read that and understand. All right. I think that is that working. We've got code coverage working. We have it working here. Let's add a little bit of documentation. Returns the offset of the latest of the last message. Of the last produced message plus 1. Returns just to document this, I'm going to slightly rewrite this. I'm going to say watermarks high offset equals 3, because then we can write returns high offset of the last produced message plus 1. And then another assertion for the low offset. It's just, I find it really useful in order to write these messages in assertions, because you can read the test back later, and it's actually code that runs rather than comments. And in my mind, comments is code that doesn't run, and code that doesn't run is full of bugs. Hence the full coverage idea. Returns low offset of the first produced message, the first message in the log. Lost. First message in the log. Yep. Now I'm actually going to turn these around, because I think I always want to test sort of the main use case first. And most of the time when you call watermarks, you will have stuff in your thing. It's just that we developed it this way around. Because now I can say here, t equal watermarks low offset, or high offset first, that's what we did there. Returns high offset of 0 when message log is empty. Sweet. T equal watermarks high low offset. Returns low offset of 0 when message log is empty. Cool. Now we can remove this. Hopefully when I hit save, this will test again, and it will actually work. No. Oh, because of course I need to actually use this assertion correctly. Right? Right. Does not reach its global threshold. So I have found in this whole, I'm going to actually run them all again, the entire suite, because I found that sometimes the mechanism that tries to decide what to run and what not to run in the tests doesn't always get it completely right. And so sometimes I just feel the need, especially when I see a code coverage issue, to just run all the tests. And luckily that's very quick, so it's not really an issue as of yet. But I think that's because it's a little bit of there's a, not all coverage of each module comes exactly from one test suite. So in this case, a little bit of the coverage of this local assignment context actually comes from the task test, because it tests the inject method to its whole. And maybe that's wrong. Maybe that should be in there as well. Maybe that's what this is trying to tell me. But for now, I guess that's the way I've done it. And so it's not always... sometimes I need to rerun the entire thing. A lot of the time, as you saw earlier, it does get it right. So I'm not exactly sure what the thing is that influences that. Good. Sweet. Now, time to commit some stuff. Ooh, I remember to up the thing here. No, we're not using Lodash, so that's fine. We can remove that again. Here you can actually see what I've been doing. Friday, Thursday, that was all off stream. Friday the 16th, actually quite a bit. So how are we going? Let's actually write what we've been doing. So implement and the now there's probably a couple of things now that we have this already messages in our thing that we could try to change in our test interface.inject. What is there anything else we need to cover there? I guess because of the whole code coverage thing, I don't even really have to bother, right? Like, so I'm asking myself, are there cases in where the test interface.inject won't work correctly in the way that it's assigning new offsets and stuff just because I've injected a message like this. But I guess the code coverage is sort of giving me at least a part of an idea about that, and it's saying no, probably it's probably working the way it should be working. Obviously, it's just doing code coverage over it's not checking whether I've tried every single situation. It's just trying to measure whether I've called every bit of code that we have. So I guess I can't fully rely on that. But anyway, there's one more thing here that I probably want to do. That also has to do with seeking. Because we're going to have to deal with what happens when you seek higher than the highest offset, and also what happens when you seek lower than the lowest offset. For that, we need to be able to create a situation where the lower offset is actually smaller than 0, because we can, on the outset, already say that seeking to -1 or -2 is actually... seeking to a negative offset is generally not allowed. There are actually two sort of magic numbers, -1 and -2, which indicate the beginning of the... in seeking, that basically, I think -1... is a logical offset, the logical offset of the highest offset, and the low offset is -2 is also a logical offset. But anyway, we need to be able to create a way that the offset is higher than that. We start off with the offset higher than 0, because in real life that's going to happen. All the messages are going to be garbage collected, and then the lowest offset might be 4, and we inject 3 new messages, and then it's, instead of 0 to 3, it should be 3 to 7, right? Right. So I think we should cover that as well. Should this all go under the assignment watermarks? I don't know. Maybe not. For now, that's where it's gonna go though. Async assignment. Watermarks. So let's call that again. Actually, we can just let's just copy this whole guy over. And this is the initial state thing. So let's say low offset. Yeah. We'll start with a low offset of 3. Yes, please. Note that I use a number here, not a string, because in testing, I control these values, right? So I don't want to have to deal with the whole long library and with string stuff. I just want to be able to accept the 3 here, because developer experience is also important. And then okay, and because this is a 3, that means that the low offset should be 3, and this should be 7, because it'll be all the test messages plus 1. 4, 5, 6, plus 1, 7. Yeah. Returns the low offset of the first message in the log. One I can see I couldn't spell. Returns the offset of as low. Returns the offset, because it's returned the offset of the last message in the log plus 1 as the high offset. Returns high offset of 0, 1. Yeah, okay, that's all right. Okay, let's actually stage that, and we haven't pushed anything yet, so I can just amend the commit. And as if it's always been this way. See, we don't make mistakes. No, we don't. We don't make mistakes, right? Nobody does. It's just ramming keys and pumping out the code. Now, this should fail. What am I doing here? Oh, you can see my Spotify. Oh no. I have excellent music taste, so you can have a little look at that if you want to. Got some really nice playlists. If I do say so myself. So I've actually learned to read these tabs. Actually, for the viewers of my earlier streams, you could see that I was dealing with tape a little bit. Not sure how tape works, but now that I actually I know at some point I just took half an hour to read through the documentation, and it is actually really, really nice. And when you think about it, a lot more straightforward and idiomatic than a lot of the other test suites. Actually, it just runs through code, and actually all these output it generates. It's actually really once I know what I'm looking at, it was like it's actually quite nice to deal with, because there's massive fill, and then this is the code, and it's nicely highlighted, and it's just, I had to get used to it a little bit because there was just so much happening, so much on the screen. But now that I am used to what's there, I actually really like it. So if you want to have a look at that, go to Node.tab.org. Ooh, Node.tab. If you like the logo as well, it's cool. Anyway, that was an aside. First message. So I'm gonna have to implement the whole thing that our initial offset might be lower than 0, and I think that's actually gonna complicate this stuff quite a bit. Initial offset. So let's set what our default is here, because we just made that a thing, didn't we? Yeah. Initial state. Messages, low offset. Let's set that to 0. Is that actually the low offset, or is that the high offset that we're setting? No, it's the low offset we're setting, especially when you're, yeah, sure, because when you inject these messages, because like maybe it's the high offset, maybe it's like, no, but this makes sense. Low offset. I think low offset makes sense. Low offset, cool. 0. We'll start with 0. That's the default. But we're gonna have to start using that. Should maybe probably make this immutable somehow. But initial state. So there's this whole inject method where we take the produced offset, increment it, and use the previous thing. So this is where the offset assignment happens, and it uses the produced offset. I wonder if we can set the produced offset to the initial state low offset. That might actually already just get what we want. Does it not? Doesn't seem to be specifically completely 100%. Test interface, test messages. Produce messages, where do we? Oh yeah, that's separate, good. Let's run this one. Let's just run this one alone for a second. T-test only is not a function. I thought it was. Okay, let's forget about that. Let's have a look why we're getting 6 there instead of 7. Let's just console log out all the injected messages for now. See what we're dealing with. See, we're going to get a lot because we're running more than one test. Neutral messages low. Oh wait, it's actually kind of hard to read. Maybe that's a reason. Okay, so at the first one, we've got 0, 1, 2, and the high is 3. Okay, we have to 3, 4, 5. How did I come up with 7? Oh, wait, I guess in my mind, no, yeah, that makes sense. In my mind, the first message that we would get, like we would start at 3, but the first message would actually be assigned 4, 5, 6, and then the message offsets would be 4, 5, 6, and then the next one would be 7. But obviously that's not right because we're telling it the low offset is 3, and then we're saying and these are the messages, and so then the first message should have low offset 3. Yeah, okay, cool. That makes more sense. And then we can say that this is passed. So sweet. Well, that was easier than I thought it was going to be. Sweet. Is there any way that we can document what we've been doing here? I'm just going to leave it like this for now. Can also improve that. Always improve that. Setting of initial low offset of test assignment. Cool. Now, I have about 10 more minutes to do something until I am expected to pack up and go home and make some dinner. Is there anything in here that I can still do? So we're dealing with the low offsets and watermarks is returning the right thing. We're dealing with messages that have been set. The next one is C. What we could do is actually really quickly implement code up because code up is not that difficult. Because it's basically a convenience function over watermarks. It basically although no, we need to say code up with an offset. Yeah, okay, let's just do that one. Testify, inject watermarks. Assignment watermarks. Don't know why I'm inserting it here, but I am. Thing is, I also don't want to be writing tests for these things forever, because at some point I also just want to actually run against the Kafka cluster and actually start communicating with Kafka and getting all that stuff working, and then we can return to all of these and get all the little bits fixed. Caught up will take an offset, and it will basically say, okay, given this offset, does that mean I am caught up? So does that mean basically that I'm at the end of the log? Which is, you would think that you can just take the watermarks and just see if the high is equal to 0 and stuff, but stuff gets a little bit complicated. We found a couple of little edge cases where the logic for determining whether you're caught up or not is just a little bit different to what you would think it is. So we added it, and I think I'll add it to this as well, because I remember it being a bit of a stumbling block for us. Okay, so what is this test going to look like? It's going to be another one of these. Process message with test messages. Again, probably needs to factor that out at some point, but let us take a test interface, create one, and say for a test processor, where we take an assignment, and then we basically ignore the processing part for now. We're just trying to use that assignment context that we get. And then we can basically say await the assignment caught up. Lots of empty space there for some reason. Let's just say assignment offset 2. If we're at offset 2, have we caught up? Wait, this is where your heart starts to hurt. This is where you need to start thinking about consumed offsets and the difference between a consumed offset and the high watermark. So you basically need to say, you need to be able to basically pass the offset of the last message you read into this, and it should tell you, should you be consuming more messages, or have you consumed to the end? And so the high water, as we said here, is going to be 3. So if we actually, this is dependent on the watermarks thing. So let's move it below the watermarks thing, so that if the watermarks don't work, then this definitely won't work. So that's fine. Yeah. So here's the thing: if so if I pass in the last message that I've read into this, the offset of that, if I pass that into this, and it should say, it should tell me whether I should do more reading or whether I've come to the end of the log. And so when you pass in 2 and the highest offset and the low high offset is 3, this should return true. When I am at 0, I should say false. Well, that's just, doesn't really hurt. That should return false. Yeah, I think that's true this way. I think this is and then we do need to give that initial no, we need to say test assignment. And then we give this initial, the low offset is just 0, and messages, test messages, we can even just say, because we are working with offsets here, we might as well just define it as something specific, so that if we change those default for some reason, that this doesn't die. Yeah, obviously it's not returning anything, is it? So, well, we got to get this low offset. So basically, we want these offsets. So let's get the watermarks, right? Wait, first we want to define what this offset can be. Let's just implement it the way that it would be implemented for Kafka.js, because I'm like, we can actually factor out this bit of logic for fetching the high watermark, and then pull that separate and then use that here. But I actually think that's gonna, yeah, it's actually no real reason for it. So let's just not do it. Wait to context watermarks. And then we can actually skip that, high offset, cool. And then we basically want to know whether the offset is higher than offset +1. Oh, is bigger than the high offset. But obviously the high offset is coming back as a as a string. Oh, that might be a reason why we want to. That might be a reason why we want to factor it. Inject message. Let's put this over here. High offset. Return the high offset. Low offset. Return the low offset. Cool. Okay, I've got 3 more minutes. Not gonna make that, but I'm gonna try and finish this anyway. Dinner will get cold. Well, it won't, because I wouldn't have made it. So actually, dinner might be eaten very, very hot. Last message. Let's just copy and paste, Jaap. What do you? So instead of converting it to string here, we're not going to do that. Long from string or from number. Cool. Yeah, and it says it's returning a string, so that's cool. Long from number 0, right? We're returning zeros. Yeah, we're returning zeros. Cool. And then this can just say high offset. This can say low offset. And this we can remove. And now we have this. Now we can make sure that it's a bit annoying actually. That's fine. And then we need to make sure that that offset is also a long, isn't it? Yep. That's what we need to do. how do we convert this? So basically, long is not assignable to type string. What do you mean? Local 128. Oh yeah, we had to make strings out of this. Cool. Now, then that works. So if that, I've definitely been focusing a little bit more than talking about this. But yeah, so basically I factored out this high offset and low offset so that we can internally use those things as longs and only at the last moment turn them into strings. And then here with this offset, I basically said, well, whatever comes in an offset, we'll just throw it at long. If it's already a long, the from value will turn it into a long, actually, as you can see here. A string, a number, it doesn't really matter. It will return a long. So, yeah, so that should work, right? It's easy enough. Cool. It hasn't. So let's add a to-do. Deal with logical offsets. And let's add a to-do here as well, saying the same thing. Test use of logical offsets. Cool. I'm gonna leave those as to-dos. Draft, implement, well. Time to push that. All right. Well, that's been in the end, not too bad. 90 minutes. We got some stuff done, definitely. We got a little bit wiser as how the high offsets and the low offsets should work. Struggled with TypeScript a little bit, as we do. Still have some stuff to figure out there, but type inference definitely seems to be a thing, or I'm missing something. But if somebody knows what I'm doing wrong, please let me know. I'm always happy to learn. That's exactly one of the reasons why I'm doing this. And hopefully showing that, you don't have to be afraid for not knowing stuff. Because nobody knows what they're doing, really. So I'm pretty happy with this. There is a chance I'll do some more tomorrow. There's also a chance that I'll be watching some Formula 1 instead while I do some open source work without streaming, because I must say it is really fun to stream, but at the same time I'm definitely can't get into it as much. I can't get into the zone as much while doing it this way, because I just I sort of have to explain what I'm doing instead of just flowing from one bit to bit and just doing it. I'm trying to keep everybody on board with what we're doing, and sometimes actually trying to explain what I'm doing is really it's a really good thing. Let's run this one more time to see if we don't have any code coverage issues. We don't. So I definitely want to keep doing it. Next week I won't be around. But the week after that I'll definitely try to do this again, and hopefully you'll join me or watch me, or I don't know. We'll see. So until then, have a good time, and See you later.